I'd like to introduce you to Christopher Penn, co-founder and chief data scientist of TrustInsights. He is also the author of over 2 dozen marketing books, including AI for Marketers, a primer and introduction, which I actually just purchased out there. So please welcome Chris Penn.
Thank you, everyone. All right. It is exciting to be here. I would say get closer, but we're still in 2 pandemics, so stay where you are. Today, let's talk about marketing's greatest problem. If you would, by the way, if you'd like to see this presentation and get all the materials, just go to wherecanigettheslides.com. That actually works. So marketing AI's biggest problem, well, we've heard about a bunch of problems today, but one of them is this. When CMOs were asked in the 2022 CMO survey, hey, where is AI and machine learning on your investments, right? It's down to 26% of CMOs saying, yeah, that's what we're doing. And a whole bunch of money is going into other places like data analytics, et cetera. When you ask CMOs, where do you see room for improvement? They lump AI into advanced measurement. That's kind of where they think it fits, right? Which is really weird because we've heard all day how capable it is of being used across marketing operations. And when they're asked, well, how well are you using this stuff? Right now, 11% of CMOs are saying, yeah, we're actively using AI, but 37% say they're going to do it in the next 3 years. The CMO survey is notorious for a little bit of unfounded optimism on the parts of CMOs. Every year, where people ask them, hey, are you investing less or more in marketing? And every year they say, we're going to expand our spend by 5x, and it never actually happens. So this is probably, the 11% is probably where things are going to stay for a little while. Why? Why is investment in AI so low? Part of it, and we've heard about it today, part of it is because we've sort of overcomplicated it, right? We have all these fancy terms and all this fancy technology. And we don't really need that in order to understand it, but more importantly, because we're sort of throwing a lot of jargon at it, our stakeholders don't understand it. So what if we rebrand it? Well, let's take a thought exercise. Let's, instead of saying all these advanced things and fancy software and models and stuff, what if we treated it like a blender, right? And you have this promise of this blender, these amazing blenders that can make soup and all sorts of crazy stuff. When we think about AI in the same context, a lot of the time, we misunderstand the purpose of AI, right? We don't really understand what it's doing, so we misuse the appliance the wrong way, and of course, we end up with amusing failures. Sometimes we misunderstand the mechanics of AI, how it does what it does. Now again, like a blender, how many people, if I handed you a box of parts today, how many people could assemble a blender from scratch? One person, mechanical engineer. No, you don't need to be able to assemble a blender from parts to know what it's good for, but you should know how it works, right? You should know if you put stuff in it, it gets blended up and comes out in smaller pieces. But again, with AI, because we've got all this crazy language around it, it's become very opaque. People don't understand what the machine is supposed to do. Sometimes we don't even understand the right processes, right? We're doing things in a backwards order, maybe. This happens a lot and is the topic of today's talk. We do things in the wrong order. Instead of saying, we're going to try and make soup, we take soup that's existing and we try and blend it. This, by the way, ends very badly. Don't do this. I've tried. But most of all, and where almost every AI effort fails the first few times around, is on the ingredients, right? When you put water in a blender and you expect to turn it into soup, like making something from nothing, it never happens. Here's why. We think of AI as the thing that we're trying to do, but we forget what goes into it, and that's data. Right? Data is to AI, this is for everyone who loves the SATs, data is to AI as ingredients are to cooking. Right? Data is to AI as ingredients are to cooking, which means if you have bad ingredients, right? I don't care how expensive the blender is or how good a chef you are, if the ingredients are spoiled, you're not making edible food, right? If you put sand in the blender because you don't have flour, Again, I don't care how cool the blender is, you're not making anything that's going to be edible, right? Your ingredients are bad, they're wrong, they go in, they come out blended. AI is exactly the same. You put bad data in, guess what you're getting? Bad models out. You put in wrong data or corrupted data or no data at all, and we expect this magic box to do this, and in reality, no, that's not what's going to happen. We're just going to get blended up stuff out of our models. So how do we fix this? We fix this with a process that an astonishing number of companies completely skip. Now, here's where this is going to get challenging. A lot of vendors, because they own the software, the part of this process is their responsibility, right? So if you hire a vendor to implement your machine learning, this process has to be part of their work and your work, and very often that does not happen. And the process is called exploratory data analysis. The formal definition, and the one that I really like, comes from IBM, which says, exploratory data analysis, or EDA, is used by data scientists to analyze and investigate data sets and summarize their main characteristics, often employing data visualization methods. That's cool. The big important part is that big text. The main purpose of exploratory data analysis is to look at data before making any assumptions. The main purpose of exploratory data analysis is to look at data before making any assumptions. Now, this is where I'm going to get into some trouble. When you talk to a vendor and you say, hey, I want better attribution analysis, or I want better subject lines, or I want better content, you are making assumptions. You have made assumptions about the problem before you've looked at the data. Right? So you look at your blog and say, well, gosh, our blog, we're not getting enough traffic from Google. We need AI-generated content. How do you know? You haven't looked at the data yet. Right? You don't understand the scope of the problem. Imagine what it would be like, right? If you said, hey, you know what we're going to have for dinner tonight? We're going to have steak. We're going to have steak for dinner, right? But then you go and you look in your fridge, and there's a scrap of beef in there anywhere. Are you still having steak for dinner? The answer is no, right? You don't have the ingredients. Exploratory data analysis says, look in the fridge first, see what's in there, and say, okay, we're not having steak, but we found the ingredients to make a good chicken noodle soup. So we're going to have that instead. By the way, one of my goals for this talk is to make you all hungry. So why, if this is so critical, why do so many AI projects skip this step? Part of it's governance, right? People don't have data or they don't know what to look for. Part of it's vendor integration. Again, we've got a lot of companies making a lot of promises, like, hey, this is the magic thing that's going to fix your woes. And part of it's our fault, because we've decided we want steak. And come hell or high water, we're going to serve something that looks like steak. Right? Or our executive stakeholders, pun not intended, have said this is what we're going to do. And as a result, we buy and build AI that does not have the right inputs, and nothing works. So what is this life cycle? What is this process? Again, we use fancy terms because I'm a consultant and we can charge you more money if we use fancy terms. But it really is just looking in your fridge. Right? What data do you have? What condition is it in, right? You open up your fridge and something smells really bad. You look around, okay, what expired? And it's an 8-step process, right? And we're going to go through each of these 8 steps. But the 8-step process is pretty simple. What are you trying to do? How do you get the data? What are the characteristics of the data? Take a quick look at the data, make sure it fits our problem, prepare it, engineer it, and then deploy it. That's the exploratory data analysis process. Now you can see if you're dealing with a vendor where this could break down, because the vendor is going to say, we're going to try and do all this for you. Well, a lot of it's like, okay, you can bring a personal chef into your house, but you still need to look in the fridge to make sure that you've got the ingredients. So this first part, again, this is a part that gets skipped a lot. Why are we doing this? What are we doing? Right? What is the purpose of our AI project? The easiest way to determine the purpose of an AI project is to have a user story. And a user story is something as simple as one sentence. As a, whatever you are, I need to do this thing so that I get this outcome. And you write this out pretty clearly and say, this is what I want to do. Example, as a content marketer, I need to know what makes digital marketing articles do well so that I can create a great performing article. Right? That's a pretty clear user story. It indicates some good intent. I can figure out from this statement what kinds of stuff I'm going to need in order to make a working model of some kind. At this point in the process, too, you have to take in all the other considerations that might go into a data project or an AI project, like, do we care about bias? Do we care about fairness? Do we care about an outcome that could be misinterpreted? This is where you ask the questions. How could this go wrong? Like the famous Reddit subreddit, what could go wrong? This is the time to ask that question because depending on your AI project, a lot of things could go wrong. So you establish your goal and your purpose first. Then your second step is the data collection, which just answers the question, where do we get our data? Now, as a content marketer, I want to understand what makes articles perform well so I can create great performing content. That tells me I need to have examples of great performing content. So I might go, for example, to an SEO tool. This one is Ahrefs, but you probably have an SEO tool. If you're doing social media, you might have a list of content and likes and shares and stuff like that. If you're doing email marketing, you might have a bunch of emails with opens and clicks. Any marketing data would fit this category. We just want to find out what data are we going to need. So in this case, because I care about content marketing, I'm going to go to a content tool to get the outcome that I'm looking for. And this is really important because if the data doesn't answer the question, I can't go any further. I shouldn't go any further. Our next step of the process is attribute classification. What does the raw data look like? What's in the box? If I download this data, how does it look? And this is where you have to do some inspection. Right? Again, this is stuff that probably should not be automated. When you look in the data, this is an example, I'm using the R programming language. I want to know, what did I get? What was in the box? We have things like the title of the content, the URL, the author, the domain rating, the referring domains, traffic, Twitter shares, Pinterest shares, number of words. All these things come in the box with this data. And inspecting this data is essential. You want to figure out, like, what do I have to work with? What are my ingredients? There are a lot of tools in data science toolkits in Python and R and other tools that can somewhat automate this and tell you how many discrete columns or continuous columns, numbers and not numbers. Are there any missing? Are there missing rows? How many missing observations are there? That kind of tell you the health of your data. Running this kind of very basic inspection is super important for all your marketing data. If you want an example of what it looks like to not trust your data, export your Google Analytics data and run it through a similar test, and you're going to find some surprising holes in the data. Sometimes it's self-inflicted, like, oops, we deployed a new website theme and we forgot to put the tracking code back on the website. But other times, you're going to see big, huge holes in your data all over the place, right out of a tool that you assume is working perfectly. But with things like ad blockers and privacy blockers and secure browsers and VPNs, you will actually have more holes in something as ordinary as Google Analytics did than you might assume. So this process of just looking in the data and saying how much is missing is critical. Look in your CRM, look in your marketing automation system. There are many more gaps in your data than you think. And like a bridge built by the lowest bidder, those gaps can cause some serious problems later on down the road. Tools will also help you categorize what kinds of formats are in there, because again, you want to know what you have to work with. If I see a column in my, is there a laser on this thing? Nope, okay. If I see something like date as a field name and I don't see a date format next to it, I know my data's got problems. I know it's dirty. I know something's gone wrong in the data set, and I know that I have a trust problem. I may not be able to trust it as much. If I see something like website traffic and it's showing up as a character, that means, okay, there's non-numeric data in there. Something's gone wrong in my data. And again, this is very, very common in a lot of marketing data. But more important, think about our statement, right? As a content marketer, I need to know what makes digital marketing articles do well. Well, do well is kind of ambiguous. But if I look at my data, I see there's a website traffic number and there's a traffic number. I can look at the individual traffic for each article. Okay, now I have an objective. I have something I can measure against. So instead of having a more generic user story, I can refine it and say, what makes digital marketing articles earn traffic? Right? There's a clear objective now that is going to help me in my exploratory data analysis process. Our next step the initial analysis, which answers the question, how good is the data? And again, some level of automation can help us understand there's some columns in this data set, the pink ones that contain a lot of bad data. Right? It's not in good condition. And then there's columns like the ones in blue. The data is so absent, we may as well remove them. They have no predictive power whatsoever. And again, when you think about all the things you could put into an attribution model, from a computation complexity perspective, in Google Analytics alone, at least the older version, there's 520 different dimensions and metrics. You don't need all of them. And so doing this level of initial analysis will tell you, yeah, some of these have predictive power and some of these just don't. So rather than burn a lot of compute time and a lot of computational energy, do this first and figure out what doesn't belong. You can do fancy things like histogram analyses to understand the distribution of your data. What I'm looking at here in this example is there's some things like domain rating where there is a distribution, and other things where there's just all power loss stuff, which is what most marketing data looks like. You can summarize this data, again, using any of the data science tools that come equipped in all of the free packages. This one here, I'm just looking to see how many observations are there. In this data set, we have 140,000 URLs, we have 118,000 titles, we have a mean website traffic of 459 visits per article. So we can look at this and go, okay, this data set looks like it's got some useful data in it. We can even break up the words in it and look at, what are the terms. So in this case, I was looking at marketing AI. I wanted to see all the articles about marketing AI. And the most frequently occurring terms are software reviews. Right? So in this mix, there's a lot of people creating content about reviews. That might be useful, or that might be a red flag that this data set maybe isn't going to answer the question that I want to answer, right? If I want to know what creates great performing content about this particular topic, and all I see is it's a bunch of reviews, like, okay, then we're not going to be able to get an answer here. At this point, we verify our requirements. We've done a lot of exploration, right? Does the data answer our question? If we think about it, as a content marketer, I need to know what makes digital marketing articles earn traffic so I can create a great performing article. Do we have the ingredients? This is what we want to ask ourselves. Do we have the ingredients to answer this question? Now, for this data set, I would say we've got enough. We've got enough ingredients to make it. Is it going to be ideal? Probably not. There's a bunch of other things I would love to have, but I can't get them because it's not publicly accessible. But there's enough in here, there's an outcome that's quantitative that I can measure against to build some kind of working model. So our next step then is to prepare the data. How do we get it ready for use? Remember, there's some chunks of data in here that are bad. They're just no good. We should not use them. There's other data points in here too that probably are not super helpful. So for example, things like number, the number of the article in the data set, that's not helpful. That can go. We identified the author has no predictive power. We identified that HTTP code, with the status code of the article, has no predictive power. The language has no predictive power, and the platform has so many missing fields that it has no predictive power. Again, in your data, as you're looking at it, as you're getting ready to hand it to a vendor for their use, this step is important because no vendor and no software package knows your business as well as you do. No software package and no vendor knows your data as well as you should. Right? So if you hand off just a data file naively to a vendor or to a piece of software, it's just going to take what you give it and run with it. And you're going to get models that they look good on paper, but they have no predictive power and they break very, very easily. So this step of just getting the data cleaned and removing the crap that you don't need is super important. Then we get to feature engineering. There's some stuff we need, some stuff we can get rid of, but there's a lot of things we need to create, right? Here's an example from this data set. I have a title of an article, but I don't have how long that title is. That feels like it could be something important. So I'm going to engineer that. I'm going to create that. I have things like URL length. How long is the URL? Because sometimes URLs that are really long and complex, they may be indicators that there's, it could be even something like a spam farm, right? We have the day the article is published, we have the time. Does the hour of the day that an article is published have any impact on its traffic? It's conceivable, right? If you publish an article at 3 a.m. in your time zone and your businesses in your time zone don't get started till 9, people might miss it. Does the day of the week matter? We might want to add that in. We might want to look at, is the article republished? So we're doing a step called feature engineering here. We're creating new measurements out of the data that already exists. Now, we're not adding new data into this. We're just taking existing data and sort of slicing and dicing it in different ways. There's also other things we might do to remove. Again, a lot of tools say that they do feature engineering. There's a lot of brand companies are advertising automated feature engineering, but they're doing very limited automated stuff. A lot of this stuff is stuff that you have to think about. You have to ask yourself, does this matter to my business? If you're a content marketer, the day of the week that you publish an article might be important, but the vendors you work with, unless they literally hand you their code, you don't know what they're engineering out of your data. You don't know if they have a blind spot or many blind spots. Only by doing the engineering yourself are you guaranteed that you're handing off the data that you know you want to have predictions on. There are other things where your data has what's called too much dimensionality. For example, does the website domain that an article was published matter? Maybe, maybe not, but in this data set, there's 12,930 of them. If you've ever tried to use, again, a vendor or particularly code this yourself, you know that with this much variability, it's going to take days for this model to run on a high-end laptop or in the cloud, and you still may not get a useful answer. So what could we engineer out of domain to reduce that dimensionality? We could do something like the top-level domain, like a .com, .org, .edu. That brings it down to 260, right? That is a much more manageable number, and you're actually going to get your model to run in something resembling a timely fashion. Part of feature engineering is knowing what to throw out and what to keep. And again, this is where a lot of vendors kind of fall apart because they're going to do what's computationally most efficient. So they might just throw out the thing entirely. Well, there might still be predictive power in here. We don't know. We want to run a test. And so we've got to try engineering this ourselves. And then finally, we're going to look for stuff that we know screws up algorithms. There are, for regression analysis particularly in machine learning, there's things called covariates. Right? These are variables that essentially march in lockstep with each other, and they really, really screw up predictions. Right? So in our case, we have things like website traffic and page traffic. Those pretty much march in lockstep. There's website value and page value. Those march in lockstep. Neither one is going to be very helpful, so we're going to get rid of the value versions so that we can, again, not screw up our algorithm. We're going to look for those correlations as well and get rid of fields that have no correlation to the outcome. Right? So we've created about 100 variables here. The top 10 and the bottom 10 are probably the ones that will have the most predictive power. Everything in that middle where it's kind of nothing, those are fields that don't have predictive power. We want to get rid of them. They don't help. They're not helpful. This step also helps you understand in your data if you've created variables that become problematic. Right? So for example, if you have age, or gender, or ethnicity, or any protected class in your data, and you start seeing it in a correlation report, you need to ask yourself, this is where you pump the brakes and say, are we allowed to use that data? Right? Are we allowed to use that data? And if so, what are the parameters for using it? In 2018, Amazon created a LinkedIn filtering system to try and narrow down the number of candidates for their recruiters to deal with. They trained it, but they didn't do the step of looking at correlates and covariates and predictive power, and they fed it a data set that was 95% male. What do you think happened? The system immediately stopped hiring women of any kind. Right? And Amazon had to pull the plug on it and took a pretty bad beating in public because of it. It is at this point that they should have discovered, hey, it looks like gender might have a predictive power, and we're not allowed to use gender for hiring. So let's maybe stop the project to figure out what's gone wrong with our data. But if you just sort of outsource this part, you miss that step, and then you wonder, you get a lot of egg on your face as a result. And finally, we're at a point where we now can build a model, because we can say, what are the results? Now, in this case, I used a system, an algorithm called XGBoost, extreme gradient boosting. For those who are familiar with machine learning, it's a super, super popular way just to figure out what variables matter the most. So for content marketing about marketing AI, the only factor that has statistical significance is referring domains, which means that if I, as a content marketer, I need to know what makes digital marketing articles earn traffic, it's referring domains. It's referring domains that has the highest correlation to traffic, which means that now, for this data set, I can build a test. I can say, okay, I'm going to start publishing some articles, and then I'll get my PR team to get as many referring links to it as possible. We're going to see if that has now a causal effect, right? We've got the correlation. Now we have to prove a causal effect. So this is the process of exploratory data analysis. This is what you do with a data set before you start doing machine learning and AI. If you skip all this, you could see the various points throughout the process where things can go wrong, where your data can go wrong, and eventually lead to a very wrong outcome. Now, how do you get started with this? Well, the first part is to take this framework and talk to your vendors. Talk to your data science teams internally. Ask them how they do this process, right? When you go out on the expo floor out there, any of the vendors who are out there, ask them, how does exploratory data analysis work in your product, right? When I give you data, what do you do with it? What happens to it? One of the things that is a red flag is they say, oh, it's a proprietary process. No, it's not. This is stuff that is so common. This is like a chicken soup recipe. Right? Yeah, you can have your own special twist. Maybe you put anise in your soup or whatever. But for the most part, it's chicken and water. Right? That's chicken soup. Exploratory data analysis, you probably shouldn't have any innovative tricks in what is a very common process to assure a good outcome. It's like the scientific method. This is not the place to get innovative and cute. This is the place to do it properly so that you can then apply your innovations on the AI side. A lot of people say, well, surely there are tools that do this, right? Well, yes, there are automated data prep tools that do this, but you're getting what those tools are capable of and what their limitations are, right? Instead of prepping the ingredients yourself, you're buying the pre-prepared ingredients. And by the way, this is the Trader Joe's fire-roasted vegetables. I'll tell you right now, that's not fire-roasted. If you've ever, it's kind of all soggy and stuff like that, it's not. It looks like it, but it's not. The same analogy is true, right? Automated data prep will take your data, run it through some pretty common algorithms, and what you'll get is kind of an imitation of doing it the right way. And maybe in a pinch, this is okay, but as Dr. Clavel was saying, there's a lot of cases where that's not okay, right? You want it to be done with some control. And there are companies that advertise, we have fully automated end-to-end machine learning. Now you're not even getting the ingredients. Now you're just getting a prepackaged good from them. And again, if you ever read the ingredients on a box, you go, wow, there's a bunch of things here that I can't even pronounce, much less find in my kitchen. Right? Stuff will sneak into those products that you might not want. Again, when it comes to things like protected classes and bias, a lot can happen behind the scenes. And the more automated an exploratory data analysis process is, the less control you have over it. But here's the thing, when you deploy it, you are liable for what happens, right? When Amazon deployed that hiring system, Amazon was legally liable for discrimination. When you use someone else's algorithm, when you use someone else's model, you are responsible for what it does, right? You are legally on the hook. You can't blame them. In fact, I would guarantee you, if you check the contracts you sign very carefully, there's a waiver of liability for the vendor, right? You are responsible for the output. So even though as we walked through this process today, and it looked fairly complex, there is a lot to be said for doing it yourself, at least the first few times, right? Think about cooking. If you cook the same thing every day, you probably don't need to exhaustively inventory your refrigerator every single day, right? You can just do a quick sniff test, like, oh, that carrot went bad, toss it out, right? If you're changing the recipe you cook every single day, then yeah, you probably need to check what's in the fridge fairly frequently. The same is true of machine learning and data prep. If you are doing the same exact data work every single day, maybe you're just taking in point of sale data, you need to do exploratory data analysis the first time really well, and then do spot checks. But not as rigorously, just every so often again to make sure the ingredients haven't gone bad. In AI parlance, you'd be looking for model drift. Your model is kind of going away from the way intended. But you don't need to do this rigorous process every single time. But you absolutely should do it, once or twice, maybe a year, rigorously to make sure you know what's going on. If you are using a tool, for example, like Google Analytics 4, the new version of Google Analytics, you should absolutely be looking at the raw data that it spits out. The first time you start using, go, what's in the box, right? And by the way, what's in the box changes an awful lot. 2 weeks ago, they added like 7 new fields. I'm like, oh, great. When that happens, it's time to do exploratory data analysis again. So to recap, the purpose of exploratory data analysis is to look at data before making any assumptions. So you don't make assumptions about what you're going to find. You don't make assumptions about how you're going to use AI. You don't make assumptions about the outcome. If you do, you're setting yourself up for disaster. Right? When you work with a vendor, you ask them rigorously, show me, tell me, let me talk to an engineer. How do you do your exploratory data analysis? If they say it's proprietary, you say, thank you very much, I'll calling the next vendor on my list. Right? Exploratory data analysis should not be proprietary ever. Right? It should be as open and as public as possible with your data within that vendor or your team. You can save the secret sauce for the actual modeling itself. So again, if you wanted a copy of this talk, go to wherecanigettheslides.com, and we have about 10 minutes for questions or jokes.
Yeah, I actually have a quick question. So, let's say I've got multiple technologies in my stack that are tracking the same thing, like HubSpot. Yep. How do you square 2 different data sources if they're tracked differently and captured differently?
It depends on what the outcome is. So we run into this question a lot. At the end of the day, the question is, what are you calibrating against? Like, at the end of the day, there should be something like a lead or a sale or some final result that has business impact. And that's when you go to your EDA stack, pull out your correlation stuff and say, okay, which tool most closely resembles the number that I'm really being held accountable for? So if I'm held accountable for marketing qualified leads, which of these tools does a better job of correlating to the actual marketing qualified leads? And that's how I tend to make decisions about that. And then you can ask, for the other tools in the stack that are not measuring as well, why not? What's gone wrong with those tools that they're so wildly off? The gentleman in blue here has a question.
So fancy. So I work with data scientists and data engineers, and they go through feature engineering, creating composites. What point as a marketer would be good for me to get involved with that? Because obviously, I can go through the process that you outlined, but when they're making some of those decisions on what's going to impact my target variable and where the features going to pull together, I'm a little concerned after listening to it.
So the answer to that question, I would say, depends on your data science team, right? I recommend beer. Beer on Fridays is a good way to sit. I'm not kidding. Sit down with them and say, okay, explain to me what you're doing and what kinds of data we're working with, because your average data scientist does not have marketing domain knowledge, right? They may not understand the importance of a variable, or they may not understand that a variable can be synthetically bonded to another variable to make a more interesting one, or they may be doing stuff with your data that, again, may not be permissible. So taking this framework and saying, okay, walk me through how we do our exploratory data analysis, walk me through how we're using this data, and they don't necessarily have to have you coding, but they should be able to show you at each stage, here's what we did next, here's what we did next, and then based on what you've heard and learned, you can say, well, what about this, right? This is a protected class. Are we doing anything about that? For example, if you are dealing with data that has as a protected class like race, and you have a DEI initiative at your company saying we're embracing diversity and inclusion, then at that point, your data science team should have a toolkit, a fairness toolkit of some kind to say, okay, we're going to re-weight this data that we're putting into this model to make sure that we are enforcing our DEI initiatives in our marketing itself. I saw the opposite of this happen not too long ago with an insurance company up in Minnesota, where they said, hey, we've figured out a novel problem to getting around regulations that permit us, that don't allow us to lend differently. We're just going to not market to certain groups of people. I'm like, well, that's great. That's redlining. We outlawed that in the 30s, but clearly you did not get that memo. It would be an essential thing to do with your data science team to say, like, hey, are you thinking about this throughout this process? This is a corporate imperative, or this is just morally an important thing to do. You should probably be doing this throughout this process. So that's what I would suggest. You don't have to code. Right? I code because I have no life. But you don't have to. If you have a team or you have a vendor, make them explain this stuff to you. And if they can't, that's a pretty big red flag that you don't have as good a resource as you thought. Next question.
Yeah, Chris, thank you for everything. This was very insightful. One question I had was around explicit versus implicit data. So what I found very fascinating there is, implicit data can offer some form of unbias in terms of, you collect data around behavior, engagement, etc., and you can't really control that. It is what it is. Whereas with explicit data, there may be some bias involved, right? Because you're actually shaping, whether on form or some other sense of, you're shaping how you collect the data, what data you collect. Is there anything that you can advise in terms of reliance on explicit versus implicit data? If there's maybe certain use cases where, relying on one versus the other would be more helpful, et cetera?
My feeling on that is that behavioral data is probably the most useful type of data, right? And getting away from demographic and firmographic data. Because our ability to use it is going away, right? Particularly third-party data is going away very rapidly, and because, as Dr. Clavel said, some of it's radioactive. Some of it you just don't want in your systems, period. The best example I can think of on this of behavioral versus demographic and explicit data is My Little Pony. Right? If you're familiar with the My Little Pony toy line, it's these little plastic horses about yay big that are sold primarily to 8 to 14-year-old girls. Right? Behavioral, from a targeting perspective, if you're Hasbro, that's the market you target. However, as some of you who have seen the Netflix special know, there's an entire market of 26 to 40-year-old men who really, really love My Little Pony. They're called bronies, and they have like 100x the disposable income of an 8-year-old. Right? These people will gladly drop $1,000 on all sorts of paraphernalia and merchandise. If you're focusing on behavioral data, you don't care whether it's an 8-year-old girl or a 40-year-old guy buying the thing. You care, hey, this entity just bought a whole bunch of Rainbow Dash. Like, why? What is that person doing? And can we sell them more stuff? Right? Like, oh, you might also like, I don't know any other pony names. That's the implicit behavioral data. You don't need to know who that person is to sell them more stuff. All you have to do is recognize a behavioral pattern in place saying, okay, let's intercept this purchase and see if we can upsell them something or see if we can win them back. The other thing is, as much as possible, we want to solicit first-party data from our customers as much as we can, because when somebody voluntarily gives you their information, and it's legitimate information, that is an indication of trust, right? They trust you enough to, or they want whatever you have badly enough, they're willing to give you some data for it. If they trust you with that data, then you've basically made a sale. You've just made a sale with data. That's very, very useful data, and even though it is explicit in that it was given to you with permission and consent, and so that makes that data super valuable if you're going to use it. Other questions?
So for those folks that aren't coding, if you're looking at something, you may have a marketer who's pretty data savvy. They're used to pulling data out, like Google Analytics. Are there tools that sort of help with that sort of evaluation, where you're scanning the data, like this data is not useful. These, sort of a lot of the things that you said, hey, let's look out for these things, let's look for null values, let's look for these things. Are there tools that are marketer friendly that somebody could learn?
Marketer friendly, sort of. There's definitely low-code, no-code tools that do that, but they still do require a little bit of data science domain expertise to, again, understand like a basic histogram. What's the distribution of this data? Tableau has one called Tableau Data Prep that is actually pretty useful. It's not bad. IBM has Watson Studio, of course. Dataiku has their data science studio. So there are applications that you can run, but there is still an expectation that when it does its sort of health check, it's kind of like an ingredients chart on a food, right? You still have to know like what is a calorie, what is a carbohydrate, and things like that, and know like, oh, is more carbohydrates good or bad, right? So that's what I'd say is there are tools that can generate nutrition labels for data, but you still have to know what it is you're eating. Yeah, some basics. I mean, I would love if marketers were to become both-brained, right? We talk about left brain, right brain. You kind of have to be both-brained these days to be an effective marketer because there's a lot of data and a lot of stats and a lot of math you need to use, and there's a lot of creativity that you need, and you can't rely on one or the other. Any other questions? Dad jokes. All right, well, thank you very much, everyone. Have a great rest of the event.
Data scientist walks into a bar.
Go for now.